Hey everyone, welcome back. Today we'll be looking at the fractional factorial designs. We already covered the full factorial designs in our last video. So if you've not watched our last video on full factorial designs, I will advise you to go back and have an overview what the full factorial design is all about because it lays the foundation to fractional factorial designs and many other designs that we'll be covering in our next videos. Before we look at the fractional factorial designs, let's see if you remember this structure. This is a typical full factorial design with three factors, x1, x2, and x3. You know that in a full factorial design, the number of experiments is always defined as q raised to the power k, where q is the number of levels and k is the number of factors. Here you have three factors, x1, x1, x3. So it means that k is equals to 3. And if you are considering two levels, it means that q will be equals to 2. So that we'll be having 2 raised to the power 3 experiments, which equals to 8. So this is a typical full factorial design with 3 factors at 2 levels. In a fractional factorial design, we test just half of these experiments. You can see this point, this point, this point, and this point, they have been cancelled out. This to tell you that in a fractional factorial design, instead of testing all the possible combination of the factors, we test just half of those combinations. This is very important because it saves time, it saves resources and effort while still capturing the most important information in your experimental domain. So, what exactly is a fractional factorial design? A fractional factorial design is defined as q raised to the power k minus p. Here, as we know, q is the number of levels, k the number of factors, and p is the number of fractions or the degree of fractionation. If you add minus p here, where p equals to 1, then we are going to have 2 raised to the power 3 minus 1, which equals to 4. So in a fractional factorial design, for a 2-level 3 factors, instead of running 8 experiments in a typical full factorial design, we run just 4 of those experiments. Let's consider this practical example. It is the protein extraction process where we are considering the pH, the soil concentration, and the extraction temperature as the factors. In a typical full factorial design with these 3 factors at 2 levels, we are having 8 experiments and you alternate from -1, 1, right up to the 8th experiment. Then for the second factor, we alternate -1, -1, right up to the 8th. Then for the third factor, we alternate -1 4 times, right up to the 8th experiment. This is a full factorial design with 3 factors at 2 levels. Let us build a fractional factorial design for these experiments. Here, the degree of fractionation equals to 1. So the number of experiments will be equal to 2 raised to the power 3 minus 1, which equals to 4. The first thing you have to do here is to start by building a full factorial design for a 2-factor, 2-level design. If you do that, you'll be having this series of experiments. You start by alternating -1, 1, -1, 1. Then for the second factor, we alternate -1, -1, plus 1 plus 1. We have just designed an experiment for 2 factors at 2 levels. But our experimental setup required us designing these experiments for 3 factors at 2 levels to make up the complete full fractional factorial design. So what we need to do here is to use what we call design generators. And a simple design generator we can choose here is setting x3 to be equal to x1 times x2. If we do that, it means we have to multiply x1 times x2 for each of these levels. And if we successfully do that, we are going to have this series of levels for x3. Let's make things a bit more complex. Instead of running these extraction experiments by studying just 3 factors, we've decided to add one more factor, which is the solute to solvent ratio. If we do that, then the number of factors will be equal to 4. The number of levels will remain 2, while the degree of fractionation, P, will be equal to 1. Remember that for a full factorial design, for 4 factors at 2 levels, that is 2 raised to the power of 4, we always have 16 experiments. This is for a full factorial design at 2 levels for 4 factors. So in a fractional factorial design, we expect to have half of this number of experiments, so that the fractional factorial design will be 2 raised to the power 4 minus 1, which equal to 8 experiments. So instead of running 16 experiments in a full factorial design, we design an experiment using a fractional factorial design that has just 8 runs. Again, you have to start by building a full factorial design for 3 factors at 2 levels. It is very easy starting from that basis because you know you have just 8 experiments. You know you need just 8 experiments. And the easiest way to go through this is to start by building a full factorial design for 3 factors at 2 levels. If we do that, we are going to have this series of experiments. Again, you need to choose a design generator. You need to choose a generator by setting x4, the fourth factor, equal to x1 times x2 times x3. If we multiply x1 times x2 times x3 across, we are going to have a fourth factor having this series of levels. This method is very perfect when you are limited by budget, time, or sample size. You get valuable insight without drowning in data. Just keep in mind that you may miss out some important interactions, so it's always good to plan very well. Know the interactions you need, the ones that are relevant, and the ones which you can do without in your experimentation. If you found this helpful, don't forget to smash that like button and subscribe for more tips on experimental designs. If you got some questions or you want a deeper dive, just drop in the comments below. Thanks a lot for watching and see you in the next video.